The Mi-26 is the largest, most incredible helicopter capable of lifting the greatest loads. No other country has been able to create anything of its kind. This is a very Russian helicopter. After all, it came to be thanks to one of Russia's eternal torments, bad roads. During the Cold War, nuclear missiles needed to be delivered by some means or other to faraway launch sites in Siberia and the northern Urals. The simplest way to solve this issue, and simultaneously the most complex for designers, was to create a huge helo behemoth.
The Mi-26, NATO codification named Halo, crew 5 people, maximum load capacity 20 tons, length 40 meters, rotor blade diameter 32 meters, maximum speed almost 300 kilometers per hour, service ceiling 6.5 thousand meters.
It was created exclusively as a transport and assault copter for the military. But recently, its peaceful modification, the Mi-26T, has become simply indispensable for a whole host of installation and construction works in hard-to-reach places. Wherever a super strong flying vehicle is needed, the monster Mi-26T, a super helicopter, comes to the aid. While the chopper's body is being assembled on the slipway, its filling, or the innards of the monster, are being manufactured in a neighboring workshop. The most complex parts, the manufacturing accuracy of which is measured in microns, are fashioned by cutting-edge 5-axis milling machines. This isn't even a milling machine, but a genuine processing center. To be honest, it's just a turner's dream. It's enough to simply install the workplace correctly, enter the program, and the machine takes care of the rest itself. For example, to take this hefty chunk of metal here and carve out a part like this, it takes the machine only 12 hours, while the operator is left to simply watch the magic unfold. Before the Mi-26, the world had no experience at all in creating super heavy copters. The designers had to come up with new designs, invent new pioneering solutions for the layout of choppers, and of course, introduce new materials that were both light, durable, and sometimes incredibly complex geometrical shapes. In turn, the manufacturers were tasked with manifesting all the aircraft designers' ambitious fantasies, and they did not disappoint.
Absolutely any level of complexity and any configuration, regardless of the material type.
So there's never been a case when aircraft designers have sent you the blueprints from some parts and you've then thrown your hands in the air and said, "We can't do that."
Well, up to now, there hasn't.
First of all, the blueprint goes to the workshop programmer. Based on this drawing, he compiles a program for each specific machine and specific part. It used to be the case that transferring a workpiece from a milling machine to a fraser, then from a fraser to a drilling machine, and afterwards from a drilling machine to a grinding machine would take hours of production time. Almost all operations are now done in one place. But it turns out that making a part is only half the battle, as now it needs to be measured correctly. But how? If, for example, a part is such a very complex shape, then you'll end up torturing yourself with calipers and a ruler. To that avail, there's a special control and measuring machine. It can measure anything. On top of that, it's accurate to 3 microns, which, by the way, is much less than the thickness of a human hair. Controlling a computer program, the measuring head literally guides itself along the parts, encompassing them from all sides. An artificial ruby is installed at the end of the head. A beam of light is passed through it, and as soon as the light coming from the gemstone begins to bend, the system understands that the ruby is rested against the wall of the part. This is how ultra-precise measurements are taken. All parts manufactured in this workshop are subject to meticulous measuring. As soon as inspectors give the green light, the components are sent for assembly. By the way, they're also constantly attempting to incorporate new technologies. Just 10 years ago, the same Mi-26 was assembled here differently than it is today.
Naturally, we're evolving. We're introducing some changes to our processes. We're trying to improve labor conditions for our workers and, in turn, reduce labor intensity and increase productivity.
One thing that remains unchanged is the quality and reliability of this machine. It is operated in the most extreme conditions, at high altitudes when its loading power has dropped sharply due to thin air, in the desert when sand has been clogged in the turbines. But perhaps the most extreme place where this behemoth has ventured is the Chernobyl nuclear power plant. It was the Mi-26 that dropped tons of water and a special liquid onto the smoking reactor, neutralizing the radiation. Later, this monster participated in the construction of the sarcophagus over the third power unit, and it was only thanks to this huge helicopter that the first responders managed to reduce the impact of the nuclear disaster on the environment. On the main slipway, all the individual parts of the machine are joined to each other. The cargo floor of the side, the tail boom. In about 2 weeks, all the parts, just like the pieces of a huge three-dimensional puzzle, will combine into a single whole and turn into a completed fuselage. Afterwards, the body is rolled out, and they begin to piece together the next machine on the slipway. Here, at the so-called non-slip stage of the assembly, the helicopter's body comes into fruition. Several dozens of thousands of additional rivets are fitted, doors are hung, and the internal partitions are installed. Basically, you end up with an almost finished fuselage. The only thing, as you can see, is that it doesn't have a head yet. That will be attached to the body of our monster a little later. This is done to ease transportation of the fuselage from one workshop to another. Let's not forget, the head of the Mi-26 weighs a hefty amount and is also the most important part. Like with a person, all the control systems of this huge machine converge into it. Almost the entire helicopter is made of very thin and light aluminum, but it still weighs 29 tons and carries about 10 tons of fuel. It's no surprise that this monster is one heck of a gas guzzler. For example, do you know what this is? Nope, it's not a door, but a hole for the exhaust pipe. Everything about this helicopter is very large. In turn, the engines that must drive it are also huge. The decision was made to position them in the upper part of the hull and carry them forward a little to balance the considerable weight of the very long tail boom, which was forever attempting to rear the helicopter. Here in this area, in the upper part of the fuselage, are these flaps. They're called hoods. The same name as a car hood is used here because under them will be hidden super powerful engines, each packing 11,500 horsepower. The power is enormous, but it still needs to be converted into the very lifting force that keeps the chopper in the air. It turns out that the monster helicopter needs a powerful main rotor, the largest rotor in the world. They withstand colossal loads, for they must generate enormous lifting force. The surface of the longeron becomes so even, you can look at yourself in it like a mirror. It's so powerful that here in the workshop, for instance, turning it on is strictly prohibited. It can fry all radio electronic devices. When you stand on the helicopter, you begin to realize that it truly is a monster. The Mi-26 has a single rotor design, meaning the entire load isn't distributed over two rotors, like for example on the Chinook, but falls on the shoulders of 8 giant blades attached to the main rotor transmission.
Mikhail Leontievich Mil once said that if there are new blades, then there is a new helicopter. So, these blades were created to replace the Mi-6 helicopter.
Each blade on this monster exceeds 50 meters in length. They differ from the screw wings of the previous Mi-6 not only in size, but also in design. For the first time ever, a production technology based on composite materials was employed specially for this helicopter.
As we know, the whole world is now switching to composites, as composites are more reliable than metals. Metals are prone to corrosion, and the durability characteristics of composites are often higher.
The beating heart of each blade is a titanium longeron, or as it's called here, a pipe. Once it arrives at the helicopter factory, it's meticulously polished on grinding machines that have been specially designed and manufactured for this operation. The longeron is polished to perfection using bog-standard metalwork sandpaper. The process takes 5 days, and during this time, hundreds of meters of strips like this are completely scrubbed off. But in the end, the surface of the longeron becomes so even that you can look at yourself in it, like a mirror. After polishing, the internal stress of the metal is removed from the pipe. To do this, the entire longeron is tapped with small metal balls. After this treatment, the entire surface of the pipe is equally stressed, and the likelihood of cracks forming is significantly reduced. Parallel to this, the so-called plumage of the helical wings is gathered at the blade plant. A little later, it will be joined to that very titanium longeron. The blade is only hard on the outside. Inside, it's filled with porous material. This here is called a cell block, but it's really just paper infused with a special resin. However, since this paper is assembled into a structure reminiscent of a honeycomb, the block turns out to be incredibly durable. The honeycomb block is covered with textilite, coated with epoxy resin, and sent to the oven. After all the materials have sintered into a single hole and hardened, the finished segment is glued to the longeron. As a result, this means that one blade consists of 26 such segments. They withstand colossal loads, for they must generate enormous lifting force. But surprisingly, thanks to their cellular structure, they are incredibly light. This complex composite segment weighs only 1.5 kilograms. The finished blades are sent from the workshop directly to the airfield. They're hung on the helicopter at the very end when the other parts are finished. Meanwhile, the installation of the main systems is completed in the assembly shop. The fuselage is finally joined to the cockpit. The engines are installed under the hoods. The installation team and electricians attach thousands of wires to the dashboard and solder tens of thousands of contacts. Afterwards begins the long and grueling process of fine-tuning the equipment. The huge machine should respond to any human actions just as organically as a violin responds to a musician's bow.
We bring things to life. We're like doctors. We listen, we examine, and I always have my own slogan that our work is the work of why, meaning that every time, every day, I do the same thing again and again, but I ask myself, why is it working this way today and not like it was yesterday?
Bringing a helicopter to life takes several weeks, during which possible hiccups such as system errors are discovered and fixed, and meticulous work is performed on every single block, along with every soldering contact.
All right, Vanya, look, I didn't get a spike in AC mode, so could you please jump into the cockpit and turn on the range on the transponder control panel? Turn on AC mode. I'll give it a test from here, and if it works, I'll give a signal, okay? All right, great. Okay, let's go. Let's be quick, okay?
Yevgeny Vlasov has revived more than a dozen Mi-26s. Surprisingly, all the helicopters behave in their own way and have their own personality. Each monster has its own whims and shortfalls, which Yevgeny corrects on Earth, before the monster takes to the sky. Here, being a great electronics engineer doesn't cut it. You need to have instinct and intuition to understand what is going wrong in the kilometers of nerve endings circulating through this huge machine. It's a difficult job.
Of course it's difficult. It's very difficult. It's very difficult, and what's more, it's a complex combination of simple devices that are simple at first glance, and then the transition to very complex circuit technology.
On top of that, this circuit tech is constantly being improved. More and more new instruments are installed on the chopper that are lighter and more accurate than their predecessors. The transition from light bulbs to semiconductors alone shaved off hundreds of kilograms in weight. The only part of the Mi-26 fuselage that isn't made of duralumin is the nose cone here. It's made of textilite and coated with what's known as radio-transparent paint, and all because a very powerful weather radar is hidden under this cone. Its radius of action is 300 kilometers, and it's so powerful that, for example, here in the workshop, turning it on is strictly prohibited. It can fry all radio electronic devices. After installation is complete and all operation systems have been checked, the helicopter is handed over to the test pilots. It takes about a month from the moment the sheet casing is anodized till the vehicle is rolled out of this hangar. In fact, if you put a Boeing 737 passenger plane next to this monster, the helicopter will be longer. she?
Everything's wonderful. The machine's completed her first flight. She'll be working for a long time for the good of the people.
As soon as the pilots disembark the Mi-26, the technicians envelop it from all angles. Even if the pilots have no complaints, the mechanics will still dig their hands into the monster. Literally. After the first test flight, all the machine's components and mechanisms are thoroughly checked. First of all, naturally, the engines. Here they are, the two turbo propeller hearts of our monster. They spin the largest rotor in the history of helicopter aviation without breaking a sweat. Its diameter is 32 meters. Never have engines of such power been installed on helicopters, which is why everything is checked, from the oil pressure and blade temperature to whether the turbines are fastened to the main body. If everything is in order, the helicopter goes on another test flight, but this time it's a real exam. The Mi-26 needs to fly a distance of several hundred kilometers and return back.
Despite the size of this machine, operating it is rather straightforward, by no means any harder than flying a standard light helicopter. The designers did their best to make it possible to carry out such hefty, important tasks, such as transporting cargo on an external sling inside in the cargo compartment, while simultaneously maintaining the easy handling.
After the test flights are completed, the Mi-26 is handed over to the operating company. These monsters fly all over the world, from Canada to Australia, from scorching Africa to the freezing Russian north.